Hidden inside solid rock is one of the world's largest wastewater treatment plants, and it is here, at Henriksdal in Stockholm, that greenhouse gas emissions are no longer just estimated. They are measured. I'm Tory from Fresenius. I'm walking through a part of the facility where our gas analyzers have been installed at multiple measuring points. So, welcome to our presentation on CH4 and N2O monitoring at Stockholm's wastewater treatment plants by Fresenius. In the next minutes, we'll look at why measuring these greenhouse gases matters, where emissions occur, and how continuous gas monitoring with reliable and technical advanced solutions can support real climate transparency and process control. Wastewater treatment is a significant source of greenhouse gases, but not all greenhouse gases have the same climate impact. Over a 100-year time frame, methane warms the climate around 28 times more strongly than carbon dioxide. Nitrous oxide is even more potent at around 265 times. Serving 1.1 million people, Stockholm Vatten operates two major treatment plants with advanced biological nitrogen removal processes. Committed to full greenhouse gas transparency, the Henriksdal plant, one of the world's largest, is built entirely inside solid rock, serving 790,000 people with a capacity of 256,000 cubic meters per day. When you look at the graphic, you can see that the sampling points are spread across very different process areas. At H1, for example, methane is measured in the ventilation or exhaust line, serving the area around screens and grit chambers, primary clarifiers, biological treatment, and sand filters. At H2, in the biological treatment and sand filter area, the focus shifts to nitrous oxide. And then at H3, the measurement moves to the exhaust line connected to the sludge buffer tanks and the biogas upgrading section, where methane emissions from that area are measured. So the idea is always the same. The system captures emissions in the ventilation or exhaust lines of specific plant areas, which makes it possible to link each gas to where it is actually generated. But we're also able to capture and monitor emissions in open wastewater treatment plants. Using our new floating gas dome 300, emissions can be captured from any basin where the wastewater treatment plant operator requires emissions to be monitored. We have installed the gas analyzers 220 and 320 for continuous greenhouse gas monitoring in this project, using the cost-effective NDIR measurement principle. The gas analyzer 220 measures methane and carbon dioxide, while the 320 focuses on nitrous oxide and lower methane ranges. Both ensure measurement uncertainty of less than 3%. Unlike other analyzers on the market, our NDIR analyzers ensure extremely low drift over time thanks to the combined use of our patented zero-point calibration and dual-beam vacuum reference method, generally without the need for test gas. The gas analyzer 220 in this setting is configured for wastewater treatment plants, measuring methane from 1 to 10,000 parts per million and carbon dioxide from 5 to 10,000 parts per million with uncertainty under 3%. 5 units are installed in dedicated cabinets, featuring interference compensation and analog output for supervisory control and data acquisition data transfer. You can add up 8 analog outputs and configure them via the display menu. Of course, there are many other options available like RS-232, Profibus DP, Ethernet Modbus TCP, Ethernet IP, and Profinet for integration in your systems. The Gas Analyzer 320 is configured for measuring nitrous oxide from 1 to 50 parts per million with less than 3% accuracy deviation. It also measures methane and carbon dioxide with similar accuracy. 2 analyzers are installed in dedicated cabinets, featuring built-in interference compensation and analog output for supervisory control and data acquisition data transfer. All our products, including the GA320 and 220 shown here, can be configured individually for your project and your requirements. We are able to measure over 120 different substances and gas mixtures. Check out our website, freseniusinstruments.com, to learn more. Our gas analyzers are the most reliable solutions on the market, while having low service requirements. At Henriksdal, the wall-mounted cabinets are installed at each sampling point, ensuring proximity to measurement locations. Sample lines are routed directly from process streams to analyzer inlets. Green status LEDs and LCD displays allow local status checks. Remote monitoring is integrated via 4 to 20 mA signals into Stockholm Vatten's supervisory control and data acquisition system. All 7 instruments were installed with zero unplanned downtime, thanks to our very qualified technicians and our technical support team. Fresenius delivers dependable, continuous online measurement you can trust when uptime matters most. Powerful pumps handle long distances to the extraction point with ease, while fully automated systems reduce manual effort and keep operations running efficiently. Direct access to expert support and automated zero-point correction without the need for test gas give you confidence, save valuable time, guarantee low service costs, and help prevent costly interruptions. The result: modern, German-engineered solutions from an innovative manufacturer, designed for reliable performance and consistently low service costs. Replace assumptions with continuous verified greenhouse gas data and gain the clarity you need to achieve your climate goals and optimize your processes with confidence. Contact us today for reliable measurement solutions you can trust. Thank you for your attention.